Our solar system is not a quiet place. It is a living system in motion, shaped by gravity, carved by ancient debris, stirred by wandering comets, and revealed piece by robotic explorers. Planets migrate through space, asteroids drift between worlds. Radiation from the sun sculpts surfaces and atmospheres. Nothing here is truly still. In this series, Worlds in Motion, we journey through our solar system not as a static map, but as a dynamic system, where each world is shaped by forces still acting today. We begin at the innermost edge, a planet scorched by the sun, forged in extremes, and shaped by forces that push rocky worlds to their limits. This is Mercury. Mercury is the smallest planet in the solar system, only slightly larger than Earth's moon. It orbits closer to the sun than any other world, completing one orbit in just 88 Earth days. But a single day on Mercury, from sunrise to sunrise, lasts nearly 2 Mercury years. This slow rotation creates some of the most extreme temperature swings of any planet we know. On the day side, temperatures climb high enough to melt lead. On the night side, temperatures fall low enough to freeze carbon dioxide solid. Mercury has almost no atmosphere to redistribute heat. Instead, it has a thin exosphere, atoms blasted off its surface by sunlight, micrometeorite impacts, and the solar wind. Its surface is scarred by craters, ancient lava plains, and towering cliffs known as lobate scarps, evidence that the planet has slowly shrunk as it cooled over billions of years. In the permanent shadows near Mercury's poles, something unexpected exists: ice. Hidden inside deep craters where sunlight never reaches, water ice has accumulated, likely delivered by comets and preserved in darkness despite the planet's proximity to the sun. Mercury's origin is one of the great puzzles of planetary science. Despite its small size, it has an unusually large metallic core. The core makes up more than half of the planet's diameter, far larger proportionally than Earth's. Several explanations have been proposed. One possibility is that Mercury formed from metal-rich material close to the sun. Another is that early in its history, violent impacts stripped away much of its rocky mantle, leaving the dense core behind. Neither explanation is fully confirmed. What is clear is that Mercury's early history was violent. Heavy bombardment shaped its surface. Volcanic flooding resurfaced vast regions. And as the interior cooled, the planet contracted, wrinkling its crust like drying mud. Mercury is not geologically dead. It is geologically ancient, but still slowly changing as its interior continues to cool. For most of human history, Mercury was a mystery. From Earth it is difficult to observe, always lost in the sun's glare. Only in the space age did we finally begin to map its surface. In the 1970s, Mariner 10 became the first spacecraft to visit Mercury, revealing a heavily cratered world resembling the Moon. Decades later, NASA's Messenger mission entered orbit around Mercury, transforming our understanding of the planet. Messenger confirmed the presence of water ice at the poles. It mapped Mercury's magnetic field. It revealed volcanic plains, complex chemistry, and evidence of volatile elements locked into the crust. Now, the joint European and Japanese mission, BepiColombo, is on its long journey to Mercury, performing flybys before entering orbit to study the planet in even greater detail. Each mission has answered old questions and raised new ones. We now know Mercury is chemically complex. We know it holds more volatile material than expected for a planet so close to the Sun, and we know its interior structure challenges existing models of rocky planet formation. What we still do not fully understand is how Mercury came to be the way it is. Mercury has no moons. Its gravitational influence is too weak, and its proximity to the Sun too disruptive for stable satellites to remain in orbit over long periods of time. But Mercury does possess something unexpected, a magnetic field. It is weak compared to Earth's, but it is global, generated by motion in Mercury's metallic core. This magnetic field creates a small magnetosphere that interacts directly with the solar wind. Charged particles from the sun slam into Mercury's surface, sputtering atoms into space and reshaping its exosphere moment by moment. Mercury exists in a constant state of interaction with the sun, not shielded, not isolated, but exposed. Mercury is continually bombarded. Micrometeoroids rain down on its surface. Comet debris passes through the inner solar system. Sun-grazing comets pass perilously close to the sun, some disintegrating, some shedding dust that later impacts Mercury. Over billions of years, this constant bombardment has reshaped Mercury's surface layer by layer. Every impact excavates material. Every collision contributes atoms to its exosphere. Every encounter reminds us that Mercury sits on the front line of solar system dynamics. It is not merely close to the sun, it is exposed to the full violence of the inner solar system. Mercury is more than a scorched rock. It is a natural laboratory for understanding how rocky planets behave under extreme conditions. By studying Mercury, scientists learn how planetary interiors evolve, how magnetic fields can survive in small worlds, how surfaces change without atmospheres, how planets close to stars may form and persist. Mercury also serves as a proxy for exoplanets found orbiting close to their stars, worlds locked in intense radiation environments, stripped of atmospheres yet still geologically complex. In understanding Mercury, we begin to understand what happens when planets are pushed to their limits. Mercury is not frozen in time. It contracts, it erodes, it exchanges material with space. It continues to evolve under forces that never rest. It stands as the innermost witness to the sun's power, a planet shaped by heat, gravity, and relentless bombardment. In the next chapter of Worlds in Motion, we leave Mercury behind and travel outward to a world of thick clouds, runaway greenhouse heat, and planetary mystery. Venus. If you enjoyed this journey, like and subscribe to Skyward Space Quest and join us as we continue our voyage through a solar system in motion.